Good morning, everybody. This is Mrs. Jackson. I am creating my own video this morning because I could not find one that I liked that led you through the information the way I wanted to. So I am creating my own today. What we're going to do today is we're going to be putting together the things that we've learned the last 2 to 3 weeks, converting from mass to the mole, grams are mass, converting from particles to the mole. Particles are things like atoms and ions and molecules. Those are the two we're going to work with this week. Next week we will add in the volume. What I have showing you here is what's called the mole triangle, and you'll notice that the mole is in the center, and then on the outside we have mass and we have particles. Again, we will get to the volume business later. This will not be something you utilize at all this week. So when we look at this week's conversions, you're going to be converting from mass to particles, or particles to mass. If I give an atom sample and I want to know how much it weighs, the only way I can do that is by first converting to the mole, and then I can go from the mole to the grams. Notice that you've got arrows here. If I start with atoms, I'm going to convert to the mole by dividing by Avogadro's number. Once I have the mole, I can then convert that to mass by multiplying by the molar mass. You're going to cancel your units as you have always done. So all you're doing this week is linking some of the same steps that we've already learned. I have several examples for you. For this video, you'll need to look on the second page of the note guide. There was a little bit of a kerfuffle getting all of the examples in the right spot, and I wanted to do these first, but I put them at the end because that's how things are going. Please turn to the back of your notes, and you should find an example problem that looks similar to this one. Converting from mass in grams to particles and particles to grams, how many molecules are in 175 grams of silicon dioxide? So find that, okay? What we're going to do is we are starting with grams. That is given in the problem. So I want grams. I'm given grams. I apologize. I am given grams and I want molecules. So what we're going to do is we're going to start with the grams that we have. Okay? And if I want to go from grams to the mole, okay, the arrow that points in is the arrow right here, the red arrow, 1 mole over the molar mass. When I get out my periodic table and I look up silicon and 2 oxygens, I find that 1 mole of silicon dioxide weighs 60.08 grams. So I'm going to use this as my conversion factor to go from the grams of silicon dioxide to the moles of silicon dioxide. So I'm going to put this in the bottom because my grams will cancel grams. Grams of silicon dioxide cancel grams of silicon dioxide. And that has converted to the mole. Now I've efficiently gotten rid of grams of silicon dioxide and I have moles of silicon dioxide. But I don't want moles of silicon dioxide. Today, I want to find out how many molecules there are. So when I look at my unit, moles of silicon dioxide, what I want to cancel goes on bottom, and what I want to convert to goes on top. In this case, I know that from the mole to the particles, okay, there are 6.02 times 10 to the 23rd particles in every mole. Since I want to cancel the moles, I move the moles of silicon dioxide to the bottom, and I'm going to put 6.022 or 6.02 times 10 to the 23rd on the top. And, oh, I have to drag it. I apologize. I can now cancel my moles of silicon dioxide. And the only unit I have remaining is molecules of silicon dioxide. So that's what I wanted. To finish, all I'm going to do is in my calculator, I'm going to enter, follow with me, get your calculator, pause if you need to, open parentheses, 175 times 6.02, use your exponent, your EE key, 23rd, close your parentheses, and then divided by, open another set of parentheses, 60.08, close parentheses. You should get a really interesting little answer here. I got an answer of 1.75 times 10 to the 24th molecules. So my answer is 1.75 times 10 to the 24th molecules of SiO2. There is example, the first example from Google Slides. Okay. Let me make that a little bit bigger. I'm going to walk through the remaining examples on this note page. I encourage you to watch them all. Okay. Again, my final answer, I'm going to drag this down to my final answer, was 1.75 times 10 to the 24th molecules of SiO2. Okay, below that is another problem. Okay, it is converting 36.08 grams of carbon dioxide to molecules. I am starting with grams and I want to know molecules. So again, I'm going to start with grams, 36.08 grams of carbon dioxide, and I need to convert to the mole. Well, I've looked up my molar mass. I know that 1 mole of carbon dioxide is equal to 44.01 grams. I want to cancel my grams, so they go to the bottom. So I cancel grams on bottom, and I'm converting to the mole on top because those two have equal value. They are my conversion factor. And now I have canceled my grams of CO2. But I don't want to stop at the mole. I need to convert to the molecule. So I come down here to my mole triangle. 1 mole of carbon dioxide molecules contains 6.02 times 10 to the 23rd molecules. Because I want to cancel moles of carbon dioxide, oopsie, I'm going to put moles of carbon dioxide in the bottom to cancel. And I know that for every 1 mole of carbon dioxide, it equals 6.02 times 10 to the 23rd. Now my moles of carbon dioxide have canceled. The only unit that I have left are molecules of CO2, and that's what I wanted in my problem. When I put that into my calculator, grab your calculator and do it with me. Open parentheses, 36.08 times 6.022, second function EE 23, divided by 44.01. And I get an answer of 4.94 times 10 to the 23rd, I can't spell, molecules of CO2. Oh, goodness sakes. I'm so sorry, guys. And that's my final answer. Let me make it a little bit bigger so that you can see it. So that's how the conversion process works. Again, it's really just like what we have done the past few weeks. But now, instead of stopping at the moles or stopping at the grams, we're going to go all the way to molecules or atoms. That concludes this video. I have a second video that goes through the PowerPoint slides. So take your materials out and let's work through those. Thanks.